A stranger offers you a coin. Heads, you gain 50% of everything you own. Tails, you lose 40% of everything you own. You can flip it as many times as you like. Do the arithmetic, and this is the best offer you will ever receive in your life. Half the time you multiply your money by 1.5, half the time by 0.6. Average those, and you get 1.05. A 5% return per flip. Forever. No fees, no lockup, no counterparty. Take that coin 100 times, and the average outcome is $131,000. Now the other sentence. Take that coin 100 times, and you will almost certainly end up with about $5. Both of those sentences are true. Neither one is a trick, a typo, or a scam. The gap between them has a name. It has an equation, and it is quietly eating the retirement account of nearly everyone watching this video. Let's watch one person actually do it. He starts with $1,000. Log scale on the left, because we're about to need a lot of room. One flip per step. Let the path run. Flip 29. He is worth $1,309,000. He became a millionaire on a coin flip, and he is not done flipping. Flip 100. $5.15. Now here's the part one need you to actually sit with. He was not unlucky. He got exactly 50 heads and exactly 50 tails. Perfectly, boringly, textbook average luck. Average luck is what ruined him. Because to merely break even over 100 flips, he needed 56 heads. The coin hands him 50. That 6-flip gap between the luck he requires and the luck he gets is the entire trap, and it never closes. It widens with every flip he takes. Maybe he's just one guy, so I ran 200,000 of him. Same coin, same 100 flips, independent luck. Here are 260 of those lives drawn on top of each other. Every one of them a fair coin. Now watch the two averages come out of that fan. The gold line is the average wealth across everybody. It rises at 5% per flip, exactly as advertised, and finishes at $131,000. Nobody lied to you. The red line is the middle of the pack, the typical outcome, the person you'd actually meet. It falls at 5.13% per flip and finishes at $5.15. 25,000 times apart. Same coin, same 100 flips. One of those numbers goes in the brochure. The other one is your life. 13.45% of players finished richer than they started. 54% lost more than 99% of everything they had. Here is the mistake, stated precisely. There are two completely different ways to compute an average, and we use the same English word for both of them. The first, line up an enormous number of people at the same instant and average across them. That's the ensemble average. Many people, one moment. Time is frozen. You are averaging over parallel worlds. The second, take one single person and average along their entire life. That's the time average. One person, many moments. You're averaging over a sequence. If those two numbers come out the same, the process is called ergodic, and the average genuinely describes you. This is the assumption silently baked into almost every financial statement you have ever read. Expected return, average annual growth, mean reversion. Every one of them an ensemble quantity, quoted, with a straight face to a single human being living a single life. Multiplying money is not ergodic. The two averages don't differ slightly. They have opposite signs. And you never get the ensemble. You cannot be spread across 200,000 parallel worlds. You get one line, and you get it once. So why does it happen? Because money multiplies, and multiplication is not addition. If your wealth compounds, the quantity that actually adds up over time is not your return. It's the logarithm of your return, which means the honest question was never, what's the average of my multipliers? It was, what's the average of the logs of my multipliers? And the logarithm is concave. It bends downward, which means any straight line drawn between 2 points on it lies underneath the curve. Always. Everywhere. No exceptions. Put your two outcomes on the curve, 0.6 and 1.5. The midpoint of the chord between them is the average of the logs. The point on the curve directly above it is the log of the average, and the chord is below the curve. That's Jensen's inequality. The expected log is minus 0.0527. The log of the expected is plus 0.0488. That gap, 1/10 of a nat, is precisely where your money goes. Now undo the logarithm and read it back in money. The ensemble, half of 1.5 plus half of 0.6 equals 1.05 plus 5%. Your life, the square root of 1.5 times 0.6. 0.9487 minus 5.13%. That's the whole video. One square root. The arithmetic mean of your multipliers is what a crowd earns. The geometric mean is what a person earns. And nobody ever quotes you the geometric mean because it is smaller, and it is always smaller. But the plus 5% is real. It's not imaginary. It has to be somewhere. So where does it live? 200,000 players. 1 dot per 100 people. These are the 13% who finished ahead. These are the 54% who lost essentially everything. And this, 1 dot, 1 man, finished with $1.17 billion. 6% of all the money. In the entire experiment, in one pair of hands. 9 players, out of 200,000, hold half of everything. 9. That's 4/1000ths of 1%. Here's my favorite part, and it's the part that should genuinely disturb you. Even with 200,000 simulated lifetimes, the average I actually measured was $95,000, not $131,000. It's still too low, and it will still be too low at 2 million, and at 200 million. 200,000 lifetimes is not a large enough sample to even measure the average, because the average is defined almost entirely by people who essentially never happen. That expected return isn't optimistic. It isn't aggressive. It is a number that nobody will ever collect. So the answer is to refuse the bet, right? No, that's the boring answer, and it's also the wrong one. The bet was never the problem. The size was. Nothing forces you to put everything on the coin. Put a fraction, call it f, of your wealth on it, and keep the rest. Then your growth rate per flip is 1/2 log of 1 plus 0.5 f plus 1/2 log of 1 minus 0.4 f. Plot that against f. It's negative at f equals 1. All in, the thing we've been watching for 10 minutes. It's 0 at f equals nothing, because you did nothing. And in between there is a maximum. It sits at f equals exactly 1/4. Stake a quarter of your wealth. Heads, you multiply by 1.125. Tails, by 0.9. Geometric mean, the square root of 1.0125. 1.00623. Positive. Barely, boringly, unstoppably positive. Same coin. Same odds. Same 50 heads and 50 tails. All in, 100 flips leaves you $5.15. A quarter in leaves you $1,861. 361 times more money, purely from a decision about size. If you watched the last video, you've met this before. This is the Kelly criterion, and this is the machinery. Underneath it, Kelly was never a betting trick. Kelly is what falls out when you finally stop optimizing the average you'll never see and start optimizing the one you actually have to live in. There's a second way out, and it isn't mathematics. It's other people. 20 identical corner shops. Each one flips the same coin every month. A good month, a bad month. Plus 50 minus 40. Left alone, 75% of them are gone because each shop is one line on that chart. Minus 5% a month, each. Now change one rule and nothing else. At the end of every month, they put their revenue in one pot and split it evenly. Same shops, same coin, same odds, same product, same staff, same rent. One shop alone, minus 5.05% a month. 2 shops sharing, minus 0.27. Almost break even from a single partner. 5 shops, plus 2.97. 20 shops, plus 4.5. 100 shops, plus 4.89. Pressing up against that 5% ceiling. Nobody's odds changed. Nobody got smarter, worked harder, or found a better product. They stopped living in separate timelines. And that's the thing to understand about pooling. It isn't risk reduction in the way people usually mean it. It is a machine that converts a time average into an ensemble average. It physically moves you from the red line onto the gold one, which is why a chain of 20 stores survives conditions that annihilate 20 independent owners. It's why insurance exists, why medieval guilds existed, why family money compounds across generations, and individual talent does not. Not efficiency, not scale, ergodicity. Which brings us back to the bubble. Last video, I gave you a formula for who a bubble takes. This is why it takes them. A fund makes 50 bets, 10% chance each of returning 30 times the money. A founder makes one bet with the same odds. Expected value for both of them, 3 times your money, 200%. Identical. The fund runs 50 of them simultaneously, so the fund lives in the ensemble. Its median outcome is 3x. And only 3.5% of funds like that lose money at all. The founder runs one, sequentially, with their 20s. Their median outcome is 0. 90% of them get nothing. Same bet, same odds, same expected value. One of them is a crowd, and one of them is a person. The fund is not smarter than the founder. It's plural. That is the entire edge, and it never shows up in the pitch deck because it isn't a property of the bet. It's a property of who's holding it. So the next time somebody quotes you an expected return, a fund, a founder, a friend with a strategy, an AI company with a story about the future, the number is probably not even wrong. Just ask them whose average they're describing. Because if the answer is the average across everyone who tries this, then congratulations. You're the sample. You are not the statistic.